All right, so before I introduce the slide, I've got a question for you. If you put money into a bank and it compounds annually, which do you think will make more money, if it compounds annually or it compounds monthly? Well, if you answered monthly, you are correct because you're getting more interest more often. What do you think will make you more money, if it compounds daily or it compounds every single second? Well, of course, every single second. What if I told you that there is compound interest that you get every single moment constantly? Well, that is true. It's called continuous compounding, meaning you get interest not just every second, but every millisecond, and even less than every millisecond. And that's called continuous compounding. Now, I don't want you to think that you are getting 26% every single time it's compounding. No, in fact, that's not true. You're getting a fraction of that. Just like when it was compounding daily, you would get 26% divided by 365, a much smaller percent for each of those compounding periods. Okay, so don't think you're getting 26% every millisecond. That's not how it works. So here's your formula, and you absolutely need to get this down. This is your continuous compounding formula. So the amount that you make or you owe is equal to the principal times E, which is a number like 2.718, to the RT, where R is the interest rate and T is the time in years. Now for you calculus buffs, and there's quite a few in this class, what is E and why is E in this formula? Well, if you take the limit as n approaches infinity, thinking about compounding continuously, we're basically saying divide by an infinite number because you're compounding infinitely. Remember back to our formula here where we're dividing by n, and in this case we're letting n approach infinity because it's compounding continuously. You would think that you'd make a ton more money by compounding continuously, and that's true. But even if you let this value approach infinity, you're going to approach the value of E. It's not going to go on forever. So that's where that E comes from, the limit value. If you have no idea what I just said, absolutely no problem. Just make sure you know how to use this formula. All right, let's do two problems. Sarah's credit card debt company compounds continuously at 26% for 5 years. If she lets her $5,000 in debt sit for those 5 years, how much will she owe? Well, first of all, your heart should be like, oh my gosh, it said compound continuously. So your heart should say to your brain, I've got to use this formula because it said continuously. If it said continuously, you are using this formula here. So the amount that Sarah's going to owe is equal to her principal, her initial amount, and then times E to the RT. In this case, our rate is 26%, so 0.026. Oh, just kidding, 0.26. And then times 5 years, so that's going to be times 5. Okay, see if you can do that on your calculator. I'm going to do a separate video where you can see how to do this, but your E is located by the LN button right next to the 4. You're going to have to press the blue second button and then the LN to get your E. So check and see if you get what I get, but I'm getting $18,346.48. All right. So the only thing you have to be careful of here is just making sure you change your 26% into a decimal. All right, Titus invests $10,000, so $10,000 into a mutual fund that compounds continuously at 8% for 30 years. How much will he have in 30 years? As soon as you see continuous, you're using this formula here. So we're starting with 10,000. That comes from here. And then we've got our E to our percentage, which is a 0.08. Okay, and then a time of 30 years. Let's see what we get. You should try this too, please, just to make sure. I get 110,000 and 231. Oopsie. 231. There we go. And 76 cents. So this is quite a bit of money, right? You're starting at 10,000, you're just letting it sit there, and you're getting 110,000. What an outstanding deal. All right, before I let you guys go, I just want to reemphasize when you use each of these formulas. This one is used when you are getting interest paid once a year. This one is used when you are getting interest paid n times a year, like daily or monthly or quarterly or weekly or every second. And that n stands for the number of times in a year. So for example, if you had daily compounding, that would be a 365. If you had monthly, that n would be a 12. If you had weekly, it'd be 52 weeks in a year, so you'd use 52. This formula is the one that you use anytime you see the word continuous in your problem. Make sure you're using this one. All right, make sure you watch this video about how I use the E button on my calculator to find these values. Thanks for watching, folks.